Hi everyone. We're going to get started in just a moment. Hi everyone. We're going to get started in just a moment. All right, welcome everyone. My name is Steve Hess. I am the Director of User Experience at OpenBOM. Welcome to today's webinar, Interchangeable Parts, Revisions, or New Part Numbers. I want to be very sensitive of your time today. I'm going to time box this to 30 minutes. And I'm also trying to manage a little bit of internet delay. So if you have any issues with audio or delay or anything, please just type me a message in the chat box and I'll see if we can't make things go smoothly. So let's go ahead and get started. So what this webinar is and is not. This webinar is a 30 minutes or less discussion about part numbers and revisions and how they interact with your bills of material. What this is not is a deep dive into theory or some esoteric, dive into the theory behind part numbers and BOMs and things. It's meant to be sort of informal. These are suggestions and recommendations based on my experience in the business. So also this is a marketing free zone, so we're going to stay away from sales and marketing. Okay, I'm going to let me throw a slide here with a few definitions and just a quick little background. Description here of some terms we're going to use is part number, revision, and version. And the definitions of those are on the screen. You see down there at the bottom, I'm kind of using the word version to represent a rendition of a CAD design. Revision is the more formal sort of roll up of all those versions that we're all familiar with. So we'll be discussing part numbers and revisions today. And I'd like to revisit a slide from our last week's webinar about the two basic types of part numbers, intelligent and non-intelligent. So let me get this slide up here. We're going to be dealing with what we call non-intelligent part numbers. If you go back and watch that webinar number 5, you'll see that we kind of compare and contrast the benefits and pros and cons of both. So we will be looking at simple part numbers here today. So I also want to take a moment and introduce you to a couple of concepts that I have found to be very helpful in dealing with this topic of revisions and is it a revision, is it a part number, etc. There is a concept called form, fit, and function. It's been around for quite a while. There's some formal definitions of it, but let me give you, sort of the definition that I've used over the years. Form, fit, and function is a process or a methodology, a framework that helps you determine if a part is a revision or if it needs a new part number. If your company practices form, fit, and function, what you're saying is when you consider an ECO or you consider a change to the part, you're going to ask yourself a few questions. The obvious: does this change affect form, fit, or function? And if the answer is yes, you're going to give it a new part number. If the answer is no, you're going to give it a new revision. And I know that sounds very academic and collegiate, kind of to think about it that way, but here's the simple approach that I've always used to kind of help me really understand what that means. And what I'm saying is that I take a if I've got a bin on my shelf back in my parts department, and I reach in the box and I'm grabbing a bracket, and that box contains Rev A's and Rev B's of the bracket, and I'm putting together my product. Doesn't matter to me which bracket I grab. Rev A, Rev B are interchangeable. So what we're saying another way, and I want to dwell on this for just a moment, what we're saying in another way is that all the revisions of the part are completely interchangeable. So if they're not interchangeable, then we typically, we want to give that part a new part number and manage that in our bill of material. And we're going to see that. We're going to see that in an example. In this discussion today, our company is going to use form, fit, and function as one of the principles in how we operate our engineering department. So, we'll consider that as we go through the example that we're going to show. There's also a lot of other information about form, fit, and function on Wiki and other places. I'll give some references at the end of this presentation. I'll also share the slide deck with everyone. So here's another topic that I'd like to have you start thinking about. This one is a little more homegrown. This is something that my colleagues and I have used over the years. We kind of refer to it, and some slang as rev the bolt, rev the battleship. And it's a question that we ask ourselves, and there's some abbreviations that we use here, RTB2. And this is also another process or a framework similar to form, fit, and function. But we ask ourselves, hey, if I'm changing some minor part, or I'm changing a bolt on my battleship from Rev A to Rev B, in my example here, I've got a ladder. How far up the line do I roll those changes? Of course, I don't roll the revision on the battleship, right? That would be ridiculous. So the question is, how far do I need to go up the assembly structure to incorporate that revision so that it works for my manufacturing team? So we're going to take a look at that as well. And in an example we're going to do here, we're going to demonstrate that. So those are the two things, form, fit, and function, and rev the bolt, rev the battleship. So let's get started with the design example that I'm going to present here. In this case, I've got a CAD model of a butterfly assembly. This could be like a throttle body, some kind of metering device. We're going to make a few changes to the actuator arm on it. We've got part number 1005 is the arm. We're going to make a change to it maybe for stiffness or to lighten it or something that we've done as the part has evolved. And then later on, we're going to have some demand to make a significantly different change to that part. And we're going to ask ourselves, how does this, the framework that we're working in, does this need a new part number or not? You can see in the example here, of course, we're going to be rolling that part number to part number 1012. So I'm going to sort of go through a few slides here that sort of represent the evolution of bill of materials for these. So the first slide is going to show what this bill of material looks like, just sort of out of the box. I created this. In this case, I created this in a CAD system. I've produced a bill of material. There's a shaft assembly there. That shaft has an arm, 1005. Everything's at Rev A, and this looks, pretty typical of how I might, this might represent an initial release. So we got some demand to lighten things up. We've cut a window in the part 1005. And we used our CAD system to do that. And we probably generated another drawing of the part 1005. And we all agree that that's certainly a revision. So we roll the rev to Rev B, 1005. We either through automation or manually update our bill of material. And we can see there that we've gone to Rev B for the part. You can see the image is different for the part. Form, fit, and function. This is a, you can imagine reaching your hand into the box and grabbing either that first one without the window or the second one with the window. They're completely interchangeable. Form, fit, and function tells us, hey, I don't need to change part number, so I don't. And consequently, my upper level assembly, the shaft assembly, doesn't really feel, it doesn't feel anything different. It still sits at Rev A. I made a simple change. Form, fit, and function allows us to, we're practicing that to make changes without having broad documentation updates required, unless needed. So okay, so let's jump ahead now. We run some of those parts. We get another change. We're going into a new application. This shaft's going to be used in a slightly different application, and we're going to make what we would probably consider to be a significant change to the part. Okay, we get together as a team. We say, hey, look, this definitely fits form, fit, certainly fit and function. We're going to pull a new part number for that 1005. The new number is 1012. It's going to be a revision A. I'm probably going to make a drawing of that new part. Again, I either manually or through some automation, I update my BOM. And then we ask ourselves, hey, how far up does this revision need to roll? How far up the Battleship do I need to roll this change? And what we say to ourselves is, yeah, the upper level assembly is definitely feeling some impact. So my 1020, which we've agreed is going to be interchangeable for the rest of the upper level assemblies, but I certainly want to make a change to that on B. I can't reach into the box and pull out a 1012 and have it replace the 1005, so that assembly needs to change. Okay, and these are things that are usually agreed upon, sort of as a as a team. So there'll be an ECO or perhaps a design review, and you sit with your colleagues and you say, Josh, what are the impacts of of these changes? So these are things that kind of come out of a policy. I know in my own experience, we might typically have a checklist that's associated with an ECO traveler or an ECO form. So okay, well so let me just take you quickly through a couple of, I just like to sort of demonstrate for you what I was getting at here in my CAD. So I'm just going to open up SolidWorks real quick, and I just want you to just kind of help let you think about this a little bit. Give a moment for my screen to catch up. Okay, here we go. So we're looking at SolidWorks. Here's that valve that I've designed, and here's the arm. Now, the way that I've managed this in my CAD system is this particular arm. This was a revision change. So I went from Rev A to Rev B on this. So what I did sort of as a CAD management practice is I said, hey, look, I created a Rev B of this cutout. I just created it as a configuration of the same part. This document's going to have the same part number, 1005. So it makes sense to me to create those as configurations. So here's the one with the cutout. Excuse me. And in the case of SolidWorks, I assign that part number right there to this document. So I can simply, in my design, I can say, hey, look, I'm going to switch this arm to the arm with the cutout. So after I've done that, I use some automation. In this case, I'm using the Open BOM integration to say, go ahead and update the bill of material. And we'll see, we'll push those changes down into the bill of material. Same part number coming along. It will be managed in the rev. Okay, So likewise, I don't want to dwell on this too long here, but likewise, what I did for the longer arm was I created that in a new SOLIDWORKS document, since it will be getting a longer, since it will be getting a different part number, and then I went ahead and I managed the part numbers accordingly for that document. So these are just kind of some CAD methods that might help understand, you know, the impacts from CAD versus the bill of material. So, and I can make this assembly available as well for any of you that are interested in that. So kind of to summarize here, for the Rev A and B, I put those in a single SOLIDWORKS document or a single CAD document. And then when I changed the part number, I switched to a new document and gave it a separate part. Okay. Okay, so we've spoken a little bit about here's the bill of material in OpenBOM. So we spoke a little bit about, you know, part numbers and revisions and you know, who in the organization really needs, you know, to know about revision. If I'm using form, fit, and function, of course, I keep track of the revision of those parts in my master bill of material. But, you know, on the assembly side, in some cases on the manufacturing side, and certainly on the assembly side, you know, we've already established that revision is just not important. So using a program like OpenBOM, I can create a number of views of my bill of material. In this case, I've created one called assembly that exists just for the purpose of the people in my assembly group. They have, you know, part number, an image of what it looks like. I could have added, you know, maybe a bin location here would have been helpful. So there, you know, that's an example of a view that I might use for my assembly team. Likewise, there's others in my organization that do need to know about revision. Certainly my planning or supply people need to know about revision. So I can create a view of my data for the planning team, and I will include revision information. And so if I did have bin location or other things, I probably would not include that in my planning BOM. So here's an example where we've got one single set of data, one master definition of my BOM. We are bringing in updates from CAD, or certainly this could be done manually. We're managing the revisions in OpenBOM. We're then deciding within my organization who needs to see the data and in what form. Again, we're kind of, the engineering team is sort of making these decisions collaboratively. So with that, I'd like to return back to the slide deck. And I also want to say that this is I'm kind of visiting just the tip of the spear here on part number, revision, you know, form, fit, and function, you know, rev the Battleship, and, you know, giving a simple demo that should help you start to think about these. The purpose of this, I'd like you to come away from this webinar, you know, thinking about, hey, in my own organization, you know, what am I doing, and what decisions am I making? So I'd like to go through, you know, some closing thoughts and take some questions about, you know, for this example, what we did and the questions you might ask yourself and in your engineering team. Sure, you know, agreements that you want to make with your engineering team. So let's take a look at, make this a little larger. Let's take a look at what some of these things are. First of all, in my example, I use unintelligent, quote unquote, dumb part numbers. They're just numbers. And I understand the tendency, I understand the urge to put lots of information into the part number. It makes it harder as you're managing through BOM changes. So if you're not using intelligent part numbers now, I think that that's good. If you are, you might consider what information you have in those part numbers. Next, never ever store revision and state or phase or anything that has to do with product maturity in the part number. And the reason for that is simple. We saw what we had to do to go through to change part numbers. If I have to change a BOM structure just because a part rolled its rev, or even worse, just because I went from pre-production to production, those are things that I don't like to. I don't like to reorganize my BOM. BOMs are based on part numbers, so we certainly don't like to have to change part numbers just for what I'll call kind of clerical, business changes like rev and state. Next, use a BOM management tool like OpenBOM, which associates or relates that metadata to my part number. Very hard to do in Excel. The columns can become disassociated. So you're looking for something that's a database. It's driven by a database. So consider OpenBOM or some other tools that will manage that for you. Listen, I'm a big advocate. Use form, fit, and function and enforce it. I've got a lot of engineering and manufacturing background. I am a mechanical engineer and have done a lot of design work both with and without form, fit, and function. Take a look at it, dive into it a little bit deeper. We can do some webinars in the future that dive a little deeper as well. So please consider using form, fit, and function, and get together with your team and decide on how you're going to roll revisions up through the Battleship. So that single change to the rung on a ladder doesn't mean that we've got to roll the rev on the entire Battleship. So where do we stop? Decide on some questions that help you answer that. Form, fit, and function will help answer that question at the upper level assembly as well. So kind of get together and decide on that. The most important thing is that you're doing it consistently through your product structure and between your products. Keep track of rev in the planning BOMs so that the supply folks know what to buy. It is true that if you roll that arm from Rev A to Rev D, that there's a drawing for the Rev B that needs to go out to either the shop floor or the or your subcontractor. So Rev is a good place to put that. BOM is a good place to store that information. And create those views for the manufacturing and planning guys. Let your team consume a single source of that data. Making copies of Excel and things is hard and quickly becomes unmanageable, especially if you're just rolling a single revision. Keep in mind that with form, fit, and function, parts are interchangeable, and if they are not, get a new part number. If you're using unintelligent part numbers or dumb part numbers, that's just the next in a sequence. Again, tools like OpenBOM and others can automatically dispense those numbers to you. Plenty of numbers to go around. And we will cover more of that, certainly cover more of that in our next webinar. Okay, I'll just share this out with you. There's a few references. The wiki is always nice to kind of get grounded. There's Arena has some nice information on part numbering schemas, Beyond PLM on part identification, and get to know ASME 14.35. There's also an equivalent ANSI, on that. Every organization should have this series of documentation. It'll help you make those decisions about, what format do I want to follow? What are the standards? It tells you things about what revision letters and numbers to use and not use. So we can dive into that. So with that, I'm going to wrap this up. We've still got a few minutes, and I'd like to see if there's any questions. Please go ahead and enter any questions that you might have into the chat. I see somebody typing. You can also send any other questions or follow-ons you might have to this to support@openbom.com. Okay. Do you have a suggestion for revision numbers and or letters? Yes. Again, let's go back to that ASME guideline. I've got that in the slide deck. But I want you to be careful about, again, storing multiple pieces of information in a single field. Like we said, don't do it with part numbers. Also, don't do it with revision. I see a very common practice of using numbers for pre-release and then letters for release. And there's an argument that can be made for that, but consider this. If you're at Rev 4 or 5 in pre-release, pre-release is a buy restriction. And you say, okay, I'm going to lift my buy restriction. I'm not going to buy these in groups of 5. I'm going to buy them in groups of 100. And now you've got to roll the rev just to make a state change. That's not, that's costly. So let me give you just sort of a quick example of that. Here's an example where I've got a part in pre-release. If I'm using OpenBOM, I can just toggle that to release. So so consider that when you're deciding on when you're choosing a rev scheme and letters and numbers. There's also a list of numbers that you want to avoid, and those are documented in the spec. Do you have any better guidelines for determining when or how to roll the rev? Yeah, I know, and I know I didn't spend a lot of time on that, and that may be a topic just for a webinar. But first and foremost, agree with your organization on how you're going to do it. Get together with your team and decide, what are kind of the things that are going to go into, into rev. You're going to make decisions like, do I always roll the revision on my, on an upper level assembly, or not? I've worked on very, very large assemblies with 20 or 30 levels deep, and we often had places in that assembly structure where the rev roll-up stopped. So they would be maybe a component level or sub component levels or by levels or other things like that. So just get together with your team and decide, what a good point is to stop rolling that up. Again, create a checklist. You might just want a simple rule is I always roll the rev on the assembly one up from the part, and then after that, I don't. So again, these are kind of decisions that you want to make, as a team. Okay, let's see. All right, one more here. Okay, finally, you suggest not putting rev in the manufacturing and assembly BOMs. How does that work if our part revs are not interchangeable? The answer is it won't. If you're not using form, fit, and function, you're going to have to track rev through all the documentation. You'll also be faced with, when the rev B of a particular part comes in, you might have to say, gosh, I need to scrap, all my rev A's. And again, this is something a form, fit, and function helps reduce scrap and other waste as well. So again, this might be a good topic for the future. But if your revisions aren't interchangeable, I would encourage you to take a little extra time and start looking at form, fit, and function and see if it's a fit for your organization. So okay. All right, with that, I do want to thank everyone for attending, and certainly, again, if you have any questions or comments, please send them to support@openbom.com, and you can learn more about OpenBOM, of course, there at our website and on social media. Thanks again for everyone joining. Have a nice day. Bye-bye.